Jinan, which borders on Mountain Tai in the south and the Yellow River in the north, thrived on its abundance of artesian springs, for which it enjoys global popularity. Mountains, springs, lakes, rivers, and the city itself make an integral whole. The 9 mountains outside the city dot along the Yellow River in various shapes. The 72 famous springs crisscross the landscape. Daming Lake, the #1 spring-fed lake in China, is a jade embedded in the city. The Yellow River, the mother river of the Chinese nation, runs through the city. Viewed from afar, lotus and weeping willows are thriving across the city, imprinting the enchanting landscape on visitors' mind. Jinan, a city with profound culture and history, was also the cradle for Longshan culture, an important source of the Chinese culture that dates back to 4,600 years ago. With a time-honored history over 2,600 years, Jinan has witnessed the passing on and flourishing of its traditional culture over generations. Jinan, a vibrant city, has an area of more than 10,000 square kilometers and almost 10 million permanent residents. The regional GDP exceeding 1 trillion yuan makes it a mega city. The city features good location and transportation. It is the place where China's 5 major economic circles converge, the capital of the only coastal province in the Yellow River Basin, and a hub between Beijing and Shanghai. A sprawling high-speed railway network connects with 254 cities across the country. The 1.5-hour high-speed railway service covers 400 million plus people. Jinan Yaojiang International Airport is an important transportation hub in China and will upgrade its flight zone to 4F class by 2025. Colleges and universities build a diversified talent pool. Abundant medical resources and services safeguard people's health. In 2020, Jinan won its 3rd consecutive National Civilized City title and China Benchmark City for International Business Environment, and was ranked as one of the top 10 cities in China with healthy and wealthy life.
Since the launch of TAIN Initiative in 2001, TAIN has evolved into TAIN 2, TAIN 3, and TAIN 4, providing an extensive R&D network to the Asia-Pacific region. Now with Asia Connect, the success story of TAIN continues to enhance cooperation in research and education activities between Asia and Europe. What contribution does Asia Connect make? Asia Connect provides high-capacity and high-quality internet connectivity for research and education communities in the emerging economies, enabling them to take part in diverse new research and education opportunities. Asia Connect provides the capacity development programs for technical engineers and NREN managers so that they can make the most out of the opportunities it provides. Connecting Asia and Europe, Asia Connect enhances opportunities to leverage the e-infrastructure with high-performance networks and research collaborations for social benefit. Asia Connect contributes sustainable development goals by bridging the digital divide and brings Asia together by fostering digital and human connectivity.
APAN is the Asia-Pacific Regional Internet Registry, or RIR. The RIRs manage the distribution of Internet number resources in their regions. This vital function contributes to the stability and reliable operation of the global Internet. APAN provides this and other services to our members and the wider Asia-Pacific Internet community.
The RIRs are neutral, non-profit organizations that operate in a self-regulatory system. Decisions about managing Internet resources are made in an open and transparent manner by the communities that use the resources. Each RIR works independently, but we also collaborate on some activities through the Number Resource Organization, the coordinating body for the 5 RIRs.
APAN serves 56 economies in the Asia-Pacific region. Our community is large and diverse with a membership that includes all types of organizations that run independent networks. Our wider community includes internet support organizations and technical standards bodies. We also engage with governments across the region to provide information on internet addressing and operations. APAN works to support a global, open, stable and secure internet that serves the entire Asia-Pacific community. APAN is funded by membership fees. Membership is open to everyone, and most organizations that receive resources and services from APAN also become members. Together, all APAN members contribute to sustainable internet resource management in the region.
APAN's core function is the distribution and registration of IP addresses and autonomous system numbers. APAN delegates these resources according to community-driven policies. The delegations are published on a public database called the APAN Quiz database. We also manage reverse DNS zone delegations for each block of addresses distributed, along with other services relevant to our role as a number registry. All of these activities are carried out with the highest possible standards of trust, neutrality, and accuracy.
APAN facilitates internet infrastructure development throughout the region through various partnerships. These projects assist in creating and maintaining a robust internet environment, such as root server deployment and supporting local and regional internet exchanges. APAN also administers ISIF Asia, a small grants and awards program that stimulates innovation in developing communities using the internet as a social development tool. ISIF Asia is part of the SEED Alliance.
Another aspect of APAN's role is to provide information and training services to assist the community in building and managing internet networks. Visit training.apanic.net for more information on our face-to-face workshops and e-learning sessions. APAN Training also holds workshops as part of our regional conferences. APAN conferences are held twice each year for the community to discuss internet operational issues such as IPv6 transition techniques. At every conference there is a policy meeting where anyone can contribute to the APAN policy development process.
In support of the vision of an open and stable internet, APAN contributes to global internet governance discussions as one of the numerous and varied stakeholders around the world. Each year, representatives from these groups meet at the Internet Governance Forum to discuss emerging opportunities and risks, share best practices, and build mutual cooperation.
If you want to know more about how you can contribute to the health of the Internet in the AP region, or if you want to become an APANIC member, visit our website at www.apanic.net. Visit training.apanic.net for more information about APANIC educational services, and visit isif.asia to learn more about how to apply for an ISIF grant. Contact the APANIC Help Desk if you have questions about any of our services.
What can you do in 1 minute? Blink a dozen times, read 0.2 pages of a book, or walk 0.04 miles. 1 minute seems insignificant. What else can be done in 1 minute? Download 3 4K movies. Transfer thousands of high-definition medical images. Or hit 10 billion yuan in online sales. You can make a big difference in just 1 minute. RateGen network success is also the sum of efforts accumulated in countless 1 minute. As an information and communications technology infrastructure and industry solution provider, RateGen has always been committed to fully integrating technology into scenarios
helping users in various industries achieve digital transformation and value innovation. Worldwide, Regia has 59 branches, more than 5,000 employees, and more than 10,000 partners. It has registered a compound annual growth rate of more than 30%. In its 6 R&D centers, Regia invests more than 16% of sales revenue and engages more than 50% of personnel in R&D every year. The company has established a whole industry chain business model that integrates R&D, production, sales, and delivery. In Regia, we are devoted to crafting essential and practical products and solutions for users. Regia specializes in network devices, network security, and cloud desktops, and has 10 product lines and more than 400 products. In the field of network devices, Regia took the lead in the data center market and became the first in the industry to launch 100 gig data center core switches and provide 25 gig, 100 gig data center solutions. Considering the characteristics of data centers, Regia adopts a self-developed open hardware and software architecture to decouple software from hardware, taking the early lead in the market. Regia provides services for multiple clients, including the world's top internet companies and China's 3 major telecom operators. Regia took the lead in introducing commercially available Wi-Fi 6 products and has the largest Wi-Fi 6 product shipments. Its intelligent wireless service solution has helped 450 million users build digitalized and visualized wireless networks. In the field of network security, to ensure the security of the entire network, Regia builds a linkage system that integrates networks and security, creating a more secure network environment. Our software and hardware security products such as Regia Security Gateways, next-generation firewalls, situation awareness platforms, and identity management platforms have helped numerous customers to enhance network security, including more than 70 national ministries and commissions, more than 2,000 local government users, more than 1,000 healthcare units, more than 1,600 universities, and thousands of large and medium-sized enterprises. In the field of cloud desktop, Regia is the first to apply desktop virtualization technology in computer classrooms by launching the Cloud Class solution. The company also provides a unique solution that integrates virtual desktop infrastructure and intelligent desktop virtualization, allowing cloud desktop to adapt to various scenarios and ultimately supplant commercial PCs. Cloud desktop terminal shipments reach more than 2 million units, ranking first in both the VDI and IDV enterprise class terminal markets. In education, Regia works with teachers and students to empower classrooms with technology, conceiving a future through smart education. Regia Networks continuously brings momentum into the new infrastructure. Scenario innovation drives the digital future.
四三动拐次下升线，广州自强州。
programa que tiene una arritmia leve.
From China to the world, digitalization is reshaping everything we know and driving the rapid rise of a new economy. As the leader in digital solutions, H3C endeavors to promote various industries to accelerate digital transformations via Digital Brain. By accelerating the construction of digital government, we help build new smart cities, promote government services, economic development, and people's well-being, make digital government easy to reach. Relying on the cloud and networks carrier business strategy, complete access, aggregation, core, backbone network routers equipment, and full domain cloud infrastructure, we are deeply involved in the construction of carriers' 5G, IP networks, communication network clouds, and IT private cloud, facilitate carriers to fully achieve business transformation. Through the construction of education informatization, we help build digital brains to create smart campuses, enable teachers and students to enjoy the education revolution. With our digital information platform, we help build digital brains to promote the construction of smart healthcare, make smart medical treatment accessible to all. Through the intelligent digital platform, we help build a three-dimensional transportation system and promote smart travel in an all-around way, make smart transportation reach everywhere. With our digital financial architecture and full-stack cloud strategy, we provide financial institutions with full-stack products, solutions, and services to accelerate the digital transformation of our customers, get digital finance fully deployed. With our robust digital capabilities, we provide enterprises with comprehensive one-stop infrastructure services. Let enterprises accelerate their digital transformation. Through the end-to-end and full-stack digital innovation strength, we create an integrated digital platform for engineering buildings to fully release the value of data, make buildings smarter. Based on deep insights into industry needs and cutting-edge technologies, we develop mature digital products and solutions to satisfy various application requirements, serving 900 million netizens with innovative services. Make the Internet enter the era of 10 gigabit. The amazing digital achievements result from the strengths that have been accumulated for years. Rooted in China, we have 2 headquarters, 7 R&D bases, over 50 sales and service offices. Serving the entire world, we have 7 overseas branches and apply our products in nearly 100 countries. We take technical innovation as the core engine for growth. We are dedicated to developing technologies with independent intellectual property rights. We actively explore new areas of technology for the future. We fully support the construction of global scientific and technological think tank. We are building an open and mutually beneficial digital ecosystem. We share innovative digital achievements with the world, creating widespread digital success stories. We actively undertake corporate social responsibility, make digitalization more powerful, and make our society warmer. Integration empowers technology. Digital future has infinite value as it is shared by everybody.
HDC is dedicated to providing comprehensive digital solutions that are based on in-depth industry insight. In this way, we hope to help customers from all walks of life to accelerate digital transformations and business innovation, thus boosting the well-being and happiness of people. Together with us, build a digital future for better lives.
H3C, the leader in digital solutions.
Hello, everyone, all friends on site and online. May I have your attention, please? Good morning, good afternoon, and good evening. I'm Jie An from Cernet at Tsinghua University. I'm very happy to announce the opening ceremony now starts. Let me introduce the chair of today's opening ceremony, Dr. Bo Yang. He is a professor at the University of Jinan, the deputy director of Quancheng Laboratory, and also the counselor of Shandong Computer Federation. Please, Professor Yang.
Distinguished experts and scholars, friends and guests, good afternoon. I'm Bo Yang, Deputy Director of Quancheng Laboratory. In this summer season, we gather in Jinan, Shandong Province, to hold the grand meeting of the 54th Asia-Pacific Advanced Network, APAN. First and foremost, I would like to, on behalf of Quancheng Laboratory, express my warm welcome to all experts, scholars, and guests presenting at the meeting online and offline, and convey my heartfelt thanks to all friends concerning and supporting APAN. We are privileged to witness the hold of the 54th APAN meeting in Jinan, Shandong Province. While presenting the recent progress in Internet technology and the development and research of Internet technology applications in the Asia-Pacific region, it breeds new opportunities for international cooperation and development, prospect to advance Internet technology in the People's Republic of China, Shandong Province, and Jinan City. First, please allow me to introduce the guests presenting at the offline meeting. They are Professor Jianping Wu, academician of Chinese Academy of Engineering, Dean of Institute for Network Science and Cyberspace of Tsinghua University, and Director of Quancheng Laboratory. Let's welcome Professor Jianping Wu. Bin Sun, member of the Standing Committee of Jinan Municipal Party Committee, Vice Mayor of Jinan. Let's welcome Mayor Bin Sun. Professor Jilong Wang, tenured professor of Institute for Network Sciences and Cyberspace of Tsinghua University, chairman of Asia-Pacific Advanced Network. Let's welcome Professor Jilong Wang. The keynote speaker of the offline meeting, Professor Dan Li from Tsinghua University. Let's welcome Professor Dan Li. Xi Wuchen, Director of Jinan Science and Technology Bureau. Let's welcome Mr. Xi Wuchen. Jun Zhang, Secretary of the Licheng District Committee. Let's welcome Jun Zhang. Ming Xu, Mayor of Licheng District. Let's welcome Mr. Ming Xu. Also present at today's opening ceremony are comrades from relevant governments and other departments in Jinan, and friends from the press and media. Let's once again express our sincere welcome to all distinguished guests and colleagues participating in the meeting offline and online. For the first phase of the opening ceremony, let's extend our warm welcome to Bin Sun, member of the Standing Committee of Jinan Municipal Party Committee, Vice Mayor of Jinan, for delivering his speech. Let's welcome.
Distinguished Jianping Wu, Academician of Chinese Academy of Engineering, Distinguished Chairman Jilong Wang, experts and scholars of Asia Pacific and Advanced Network, ladies and gentlemen, friends, good afternoon. With farewell to summer will greet the advent of autumn. I'm privileged to get together with famous experts and scholars worldwide in Jinan to witness the opening of the 54th Asia Pacific Advanced Network meeting. I would like to hereby, on behalf of Jinan Municipal Party Committee, Jinan Municipal Government, send my warm congratulations to the successful holding of the 54th meeting and extend my sincere welcome and thanks to all distinguished guests presenting at the meeting. Jinan is the capital city of Shandong Province, a major economic and cultural province on the east coast of China. In a bid to accelerate the deep integration of the internet, big data, blockchain, artificial intelligence with the real economy, Jinan fully implements the national strategies such as Digital China, Network Powers the Nation, and Intelligent Society over the years. Jinan has established 11 large-scale network data centers with its storage resources data centers ranking the top in Shandong Province. The new generation Shanhe supercomputer developed in National Supercomputer Center in Jinan topped the IO 500 list of the 2022 International Supercomputing Conference and significantly reflects the best results in the history of the list. The server production and sales volume of Jinan ranks first in China and second in the world, and the AI server production and sales volume rank first in the world, and more than 50% of the domestic AI computing power comes from Jinan. Jinan proved to build the National Spark Network Supernode, has put into operation a national-level internet backbone direct connection point, and released and launched the first deterministic network in the world, marking that Jinan has both entered the forefront of the country's new first-tier cities. APAN has committed to promoting economic network development, application of technological innovation, information sharing support, and international cooperation and exchanges as a key foundation and broad platform for global network innovation and development. In July last year, Changchun Laboratory established under cooperation between Jinan and the Tsinghua University. And the laboratory initiates major topics on network technology, construction, future network, trial facility, and promotes outcomes of research and experience on network operation and management to the public. We would like to wish all distinguished guests could build a new highland and testing ground in Jinan. In the end of my speech, I would like to convey my congratulations to the successful holding of the 54th APAN meeting and sincerely wish all distinguished guests good health, successful career, and a happy family. Thank you.
Thank you, Vice Mayor Bin Sun. Next, let's extend our warm welcome to Jianping Wu, Academician of Chinese Academy of Engineering, Dean of Institute for Network Sciences and Cyberspace of Tsinghua University, and Director of Changchun Laboratory, for delivering his speech. Let's welcome Professor Jianping Wu.
Thank you, Professor Yang Bo, for the introduction. Dear me, Sun Bing of the Jinan City, Professor Jilong Wang, Chairman of the APAN, Professor Jeff Hosting from the APAN IC, distinguished guests and keynote speakers. Ladies and gentlemen, to all my old friends and new friends here and online, good afternoon, good morning, good evening, different people from different places. I'm Jianping Wu. This is indeed my privilege here representing CERNET to welcome all participants of APAN 54th meeting. Since COVID-19 epidemic has not yet been over, we have to hold this conference in a hybrid way of both online and offline. I'm very happy to see many old friends who are still having committed to the development of the Internet in Asian Pacific region, and also excited to see many new faces who are bringing free blood to work together with APAN to make our world better. Here, on behalf of the CERNET, I would like to extend my warmest welcome to all of you and express my sincere thank you for your strong and continuous support and contribution to APAN communities. In the being like of the year, APAN is now in its 25th year. We can still clearly recall the first time I attended the APAN conference. It was in the field of the 1997 in Singapore. Experts and scholars from all of the world get together to put forward their idea and suggestion for development of the Internet in the Asian region. Since then, I have to lead the CERNET team and participated in most every APAN conference on behalf of the APAN chair and host the APAN conference in China. The first time was in Beijing in 2000, which was also first APAN conference held in China, where we introduced the history and experience of CERNET, also China. The second time was the Shanghai in 2002. The third was the Xi'an in 2007. And the fourth was in Dalian in 2017. 5 years later, again, APAN 54th is the fifth conference headed back to China and hosted by CERNET. And it is a special significant as coincide with the 25th anniversary of the APAN. I hope we can take this opportunity to reveal the history, look forward to the future, and create a new chapter to better service our community. APAN was founded almost 55 years ago by a group pioneer in our region who realized the research and the education community needed more direct, high-performance paths and not have to deal with the long, slow, unpredictable, and lost paths of everyone connecting to each other, maybe through North America. It transformed the market from Asian Pacific networking, especially international connectivity for research and education. And it brings in nearly every single community and NREN, the National Research and Education Network in our region, to participate. During these 25 years, APAN have been growing and developing, and now they play the key role in the promote and academic networking infrastructure, innovation, and collaboration in Asian Pacific region. APAN works closely with the education institutions and universities in various countries to introduce advanced concepts, enhance the academic exchange, coachable, and the shared resource and promote translation collaboration. What more valuable is that APAN is not only nearing the network technology organizations, but also great importance to the network-related application, such as telemechanics and e-environment, e-culture, and e-cultures, the open science and open data, and so on. After 25 years, still the development, APAN has become the most influenced education and research network community in the Asian Pacific region, and has been important contributions to the development of the Internet in Asian Pacific and even globally. A number of the former presidents, board members, and leaders have been indicated into the Internet Hall of the Forum to acknowledge their primary contribution to APAN and the global Internet. 25 years ago, APAN founder realized the era of the Internet was coming. With joint efforts, APAN have been born and permitted the collaborative development and the Internet in the Asian Pacific region. Today, 25 years later, Internet has changed the world in all around the way, going broad in the new fifth space. Sometimes we call cyberspace. In new era of the cyberspace, APAN faces new mission and challenges. No matter what the world is changing into, that the Internet's spirit of the openness, equivalent, and the collaboration and sharing will never change. We always say one world, one networking. Sometimes we also say one world, one Internet. Thank you to APAN for once ago trust China and choose the city, Jinan City, to be the host of this conference on the main anniversary. If people have time, we can take a look Jinan City. The local people, you can to the real world, but it's online people can take maybe some picture and or some movies. Thank you for the Jinan government for the full support this conference, to the mayor for his personal presence, to all of the experts and scholars who attended this conference, both in venue and online. So special thank you for all of the staff who work hard behind this game. Dear friends, let us work together to continue the spirit of the Internet, strive to study Internet technology. Communication and sharing contributed development at the global Internet. Jointly, they built the community of the sharing feature and the cyberspace, and a great, better cyber world. Thank you all very much. Thank you.
Thank you, Professor Jianping Wu. Next, let's extend our warm welcome to Professor Jilong Wang, Chairman of Asia Pacific Advanced Network, for delivering his speech. Let's welcome.
So thanks to Professor Bo Yang, and thanks Mr. Bin Sun. Thanks, Professor Jianping Wu. Thank you very much for your warm welcome speech. And on behalf of APAN Board and APAN 54 Local Organizing Committee, I hereby sincerely welcome all people to attend our meeting. And because you know, Shandong Province is a famous place of rise in Chinese civilization, and Jinan City is the capital city of Shandong Province. So please allow me to greet all of you with traditional Chinese salute. So because of this meeting, we connect Jinan City with APAN. And from this moment on, I think this city has been branded in the history of APAN. And just like Professor Wu mentioned, APAN is walking into its 25th anniversary. And in those 25 years, APAN members have worked together with communities of researchers, engineers, and users, and to understand their needs for collaboration, resource sharing, and exchange knowledge. For the first time in the world, the International Research and Education Network built up and have maintained the close relationship with communities of academic, industry, and user in research and education. APAN has grown, has expanded, and has matured over the 25 years, and accelerated that expansion over the last 5 to 10 years. We have a number of new primary members representing their economies, and several more preparing to join. We have continued to partner closely with our European and North American friends to now provide users not only with high-speed connectivities, but also multiple 100 gig paths, with more coming and configured for robust networking. Some members are now becoming direct partners in new subsea cables. This is a regional network that is increasingly dependable and becoming sustainable. We have also grown the number and range of our working groups, tackling grander challenges like disaster management and, of course, response extremely to the ravage of the pandemic within and across our members. Our members have also worked to share information more easily and improve our marketing and communications, including our emerging newsletters. Over the last 5 years, we have also significantly improved our financial situation. Our administration appointed a new secretary and increased the number of projects we are participating in, including with the United Nations Educational, Scientific, and Cultural Organizations, the Global Open Data for Agriculture and Nutrition, and the Internet Society, and other international bodies. We have established a useful grant program that are supporting several working groups over the last few years to attract broader and richer participation. We are involving our meetings into full conference, open to all, and providing increasing support for hosts to ensure that all economies can host an APAN meeting, like Pakistan and Bangladesh, and soon Nepal. They have hosted their first ever APAN meetings and will hopefully soon host again in a post-pandemic world. Since 2020, I have been witness the pandemic impact on APAN's activities and also the greatest efforts and contributions of all APAN people and APAN friends, which made for amazing and successful APAN conference during this difficult period since 2020, and tried to keep the big APAN family as close as we can. So congratulations to all of you, and thank you very much. APAN members are looking forward to the next 5 years, to the next 10 years, and even to the next 25 years, because the world evolves in ways we cannot yet imagine. APAN 54 is the beginning of the way forward to the next day. Today, we could see the continuous enthusiasm of our APAN members and the working group for getting our friends together here and sharing their knowledge, experience, and explore opportunities and collaborations and cooperation, and discover the way to the future. I would just take some examples to show all these great works for APAN 54. At APAN 54, you could find many interesting topics at the plenaries from Monday to Thursday. For example, Jeff Houston gave his keynote on yesterday, just this Monday. Jeff shared many interesting stories of the early days of IETF and Internet, how IETF works, and how to participate. I think it's very important for APAN to share our needs and contribute our wisdom to IETF and global Internet development. And today, Professor Dan Li from Tsinghua University in China, and he will share some ideas about SevenNet, which is trying to provide a solution and a more secure Internet. And Professor Shinji Shimoju from Okesa University in Japan. He will talk about their research on sharing and utilizing data to enrich people's lives. And on Wednesday, we will have 3 keynote speakers, Professor Jianhui Li from CLTNet, China, and Professor Shebei Ken from UNESCO, and Professor Jamie Barber from Queensland University of Technology of Australia. They will talk about their work on international collaboration on open science and open data. Two of them have been invited to APAN conference before, and we hope their activities could be further supported and promoted by APAN community and broaden the ways to the global collaborations. On Thursday, Professor Naveed Asha from Pakistan will present their project on a cost-effective and sustainable spatial-temporal air quality monitoring system. And Brooke Schofield from Australia will talk about the training of everyman project, which is related to Identity Federation. And Professor Tomohiro Marian from Japan Kyushu University will give the presentation that titled Telemedicine Before, During, and Beyond Pandemic. APAN 54 is also organizing many sessions and working groups from Monday to Friday. In the field of network engineering, routing, network security, identity federation, software-defined network and open flow, Internet of Things, cloud, AI-driven network, telemedicine, disaster mitigation, e-culture, and so on. So you could also find much efforts in APAN community put into strengthening the collaboration between APAN Pacific region and the global research and education network on the response to the challenges of epidemic prevention and control, and the solution to help post-epidemic economic and education recovery, and to build a shared future in the new era of cyberspace. I would recommend all participants to visit our fantastic virtual exhibition hall, because all our sponsors will show their research works and products there. This is the first time for APAN online conference to try this. The link could be found at the APAN 54 webpage and program page. Please do find some time to take a look. Regarding my appreciation, I would firstly thank APAN 54 sponsors for giving us strong support to organize this conference. They are Platinum sponsor H3C, and Gold sponsor Huawei, Silver sponsor Ruijie, and Bronze sponsor APNIC and Asia Connect. Besides the virtual exhibition hall, if you are interested in talking to the sponsor, you could find 1 hour online session with sponsor at noon, which is shown on the program page. The next is my sincere thanks to APAN 54 local organizing committee on their great work of this amazing APAN 54 by overcoming many difficulties. This team, including the team from CERNET, from Tsinghua University, from Quancheng Laboratory, and all our colleagues from CITNet. You may notice the long list of APAN 54 log team members on the website. My sincere appreciation will also be certainly extended to APAN Program Committee, Technical Committee, WG chairs, session chairs, and APAN SEC. They all played a vital role in this event. They made brilliant programs, provided technical solutions to our online meetings, and invited great speakers. Finally, I hope all of us could find our interest and find fun in APAN 54. And I wish APAN 54 a great success and looking forward to meeting you in person in the near future. So thank you very much.
Thank you, Professor Jilong Wang. Dear scholars and friends, ladies and gentlemen, that's all for the speeches of the guests at the opening ceremony. Now let's go to the keynote speech of the conference. Please allow me to transfer the following moderator to Professor An. Let's welcome Professor An.
Thank you very much, Professor Yang. I'm very happy to take over the the work of the chair of today's ceremony. Now we are moving to the ceremony plenary. We have two keynote speakers. The first keynote speaker is Professor Dan Li. He is a full professor in the Department of Computer Science at Tsinghua University. His main research area is trustworthy internet, network intelligence, and data center networking. He has published more than 100 papers of top conferences and top journals. Today, he is going to share his research activities of SoftNet. For saving time, if you have any questions, please leave them in the chat box, and I will forward these questions to Professor Li. So, Professor Li, please.
Everyone. Thank Ms. An for the introduction. I'm Dan Li from Tsinghua University. It's my great honor to attend the APAN meeting and give a keynote speech here. So today, I will introduce our recent work in IETF about more accurate and more incentive source address validation in the internet. The work is led by Professor Jianping Wu in Tsinghua University, and I am one of the team members. So first, I will introduce some background knowledge. SOV is for source address validation. It is both important and challenging in the internet because source address spoofing is an old problem which may lead to various malicious attacks in the internet, represented by reflective DDoS attack. In April this year, ISOC, or Internet Society, replies to NOI, that is Notice of Inquiry of FCC, about the routing security problem. In this reply, ISOC defines source address spoofing as one of the three threats of routing security in the internet, and the other two are route hijack and route leakage. To defend against source address spoofing, network devices deploy SOV to permit traffic with valid source addresses and block traffic with invalid source addresses. However, source address validation is also challenging because we have to simultaneously satisfy the goals of accuracy, incentive, and cost. For accuracy, we need to avoid improper block problem and reduce the improper permit problem as much as possible. And for incentive, we need to guarantee that if SOV mechanisms are partially deployed in the internet, the early deployers can get some benefit. And for the cost problem, we need to guarantee that the deployment cost is affordable. So this figure just shows a typical attack caused by source address spoofing, that is reflective DDoS attack. We can see that an attacker located in AS1 can send a request to AS2 by taking the victim, that is AS3, as the source address. When the reflective server in S2 replies to the request, the responding traffic will be sent to the victim network, that is S3. So by this way, the reflective DDoS attack, which spoofs the source addresses of the victim, will be successful. And there are other potential attacks caused by source address spoofing, such as blind attacks, including single packet attack, flood-based DOS, poisoning attacks, spoof-based worm or malware propagation, or accounting subversion. And there are also some non-blind attacks, such as man-in-the-middle attack or third-party wrecking. These possible attacks caused by source address spoofing are well documented in RFC 6-line, 5-line. Actually, source address validation is an old problem with a long history of attention in IETF. As early as 1998, RFC 2267 and 2827 propose the ingress filtering or ACR-based SOF to defend against source address spoofing. But the problem of this technology is that it requires manual configuration from the network operators. In 2004, RFC 3704 proposed the strict URPF and the feasible URPF. But the problem is that it may cause improper block under asymmetric routing in the Internet. In the same RFC, feasible URPF and loose URPF are also proposed. However, it has another problem, that is, it may cause improper permit of the source address spoofing traffic in the Internet. From the year of 2012 to 2017, SAVI working group was formed in IETF. It produced 6 RFCs with a focus on host-level source address validation in access networks or enterprise networks. And the most recent effort in IETF about SOF mechanism is EFP URPF, or Enhanced Feasible Path URPF, which was defined in RFC 8704. Its purpose is to mitigate the problem of strict URPF or feasible URPF in some cases. However, we still need new intro and interdomain SOF mechanisms. In RFC 5210, the SAVA architecture divides the source address validation problem into 3 check-in levels. That is access network SOF, intradomain SOF, and interdomain SOF. Although SAVI working group for access networks is enough for enterprise network or access network, it is not enough for the entire Internet, because the number of operators for access networks is so huge that it is difficult to require all access networks to deploy SAVI mechanism. And when some access networks do not deploy SAVI, intradomain and interdomain SOF can help filter the spoofing traffic as close to the source as possible. However, existing URPF-based technologies for intradomain and interdomain SOF mechanisms is not enough because, as aforementioned, strict URPF, feasible URPF, and loose URPF have the well-known improper block or improper permit problems. And the EFP URPF does not completely solve the problem. So next, I will just describe the gap analysis and the requirements of intradomain SOF mechanism. As aforementioned, the ingress filtering technology defined in RFC 2827 and 3704 is the current practice of intradomain SOF. It includes both ACR-based SOF and strict URPF. For ACR-based SOF, it manually configures the filtering rules to specify which source addresses are acceptable. And for strict URPF, it requires the routers to look up the source addresses in the local FIP and requires that the incoming interface be the same as the corresponding forwarding interface. There are 2 other alternative implementations of ingress filtering. That is feasible URPF and loose URPF, but they are not suitable for intradomain SOF due to their overly loose validation. This figure shows a typical adoption of ingress filtering for intradomain network. We can find that there are 6 routers. Router 1, 2, 3, 4 deploy ingress filtering. And router 1, router 2 connects a subnet, subnet 1. Router 3 connects to subnet 2, while router 4 connects to subnet 3. There are 2 other routers, that is router 5 and router 6. They do not deploy any ingress filtering mechanism because they are intermediate routers. They are not edge routers. So for this scenario, existing SOF mechanisms for intradomain network has several problems. The first gap is improper block problem. Let's focus on subnet 1, which directly connects to two edge routers, that is router 1 and router 2, but it only advertises half of its address space to one of the router. So in the two routers, either in router 1 or router 2, the fib table actually is asymmetric in this case. So if the subnet 1 sends traffic to router 1 with the source prefix of the IP address that is advertised to router 2, there will be improper block problem. In this case, the improper block problem comes from that we directly applying strict URPF mechanism in interface 1 of router 1. But if we apply ACL-based solve mechanism in router 1, it requires manual update given prefix update or topology update in subnet 1. The second gap is about the vulnerability problem in the inbound direction. The ingress filtering-based mechanisms only works for the traffic that are sent out from the subnet directly connecting the edge routers. However, if there are outbound traffic which comes to the gateway router, such as router 5 or router 6 in the network, by forging the source addresses of the intra-domain network, like the prefixes of P1, P2, and P3. In this case, ingress filtering cannot work at all. It means that the spoofing traffic can easily enter from the inbound direction for intra-domain network. And the third gap is the misaligned incentive. In some scenarios, such as CERNET, a child education and research network, although it's an intra-domain network, there may be multiple operators in the AS, such as a number of different universities, different campus network. In this case, we just assume that router 3 and router 4 deploy ingress filtering mechanism, or maybe they are just managed by some one campus network, while router 1 and router 2, which are managed by another campus network, do not deploy ingress filtering. In this case, we can only guarantee that router 3 and router 4 cannot forge the source addresses of other networks. However, we cannot prevent that the subnet 1, which is under router 1 and router 2, to forge the source addresses of the other networks, such as router 3 and router 4. It means that in this case, the undeployed subnet can forge the source addresses of the deployed subnet to conduct reflective attack. So it means that the early adopters cannot get any benefit from source address validation mechanisms. To summarize, existing intra-domain solve mechanisms has the following problems. The first problem is inaccurate validation. Existing mechanisms may cause improper block problem under asymmetric routing. And the reason is that ingress filtering only conducts solve mechanism based on local fib, which may not match the real data plane forwarding path from the source. And the second problem is limited protection. The existing mechanism may fail to block spoofing traffic from the inbound direction because the ingress filtering only works for traffic from directly connected subnets. And the third problem is misaligned incentive. Existing mechanisms may suffer reflective attacks even when the solve mechanisms have been deployed by the victim part of the intra-domain network. And the reason is that ingress filtering may constrain the behavior of the deployed subnet rather than protecting the deployed subnet from being attacked by some other networks. So we have the following requirements for a new intra-domain solve mechanism. The first requirement is that the mechanism must discover the real data plane forwarding path among routers to avoid improper block under asymmetric routing. And the second requirement is that the mechanism must work for all kinds of inter-domain spoofing traffic. So the new mechanism should be able to validate the traffic from all directions and block spoofing traffic as close to the source as possible. And the third requirement is that the mechanism must provide direct incentives to help deployed subnet mitigate reflection attacks from undeployed subnet. And the fourth requirement is that we need to control the overhead introduced to design the new inter-domain solve mechanism. Okay, this is the inter-domain part. Then let's move to the inter-domain part. In RFC 8704, it makes a good summary of recommendations for inter-domain solve mechanisms. The recommendations are as follows. For directly connected networks, ACL-based ingress filtering is recommended. And for directly connected single-home stop AS, strict ERPF is recommended. For all other scenarios in this RFC, EFP ERPF algorithm, there are two algorithms, algorithm 1 and algorithm B. Algorithm B is recommended for the customer interfaces of the AS, while loose ERPF is recommended for provider and peer interfaces. However, there are also some problems for the inter-domain scenario. In this figure, we show a typical adoption of inter-domain solve mechanism. Let's focus on AS4. It has one provider AS, that is AS5. It has a peer AS, that is AS3. And it also has two customer ASs, that is AS1 and AS2. So for AS4, it has two customer ASs. For these two customer ASs, we just enable EFP ERPF. And for EFP ERPF, the algorithm B is preferred. That is, all the customer interfaces will share the same filtering list. And for the other ASs, such as S5 and S3, we just provide a loose ERPF, so it will accept all the source addresses existing in the field. In this case, there are also some problems. The first gap is the improper permit problem. Let's consider a first scenario in which an attacker located in S5 sends a request to the reflective server located in S2 by forging the source addresses of S1. This is a typical reflection attack problem. So in this case, S4 will improperly permit the spoofing traffic from S5 because the loose ERPF will almost accept all the source addresses. And there is another scenario. That is S1 and S2, which are the two customer ASs of S4. They may just forge the source addresses of each other. And in this case, if S4 runs EFP ERPF algorithm A, it works well. But this algorithm is not recommended in RFC 8704. And the recommended one is algorithm B, which will cause improper permit problem and interface 1 of S4. So this is another scenario for the improper permit problem. And the second gap is improper block problem. Let's consider this figure in which S4 has a peer relationship with S3, while has a customer AS, that is S2. And S2 also has a customer AS, that is S1. In this case, when S1 advertises the routing prefixes, it only advertises its prefixes to S3, while does not advertise the prefix to S2. But S1 may send out the traffic by the forwarding path from S1 to S4. That is S1, S2, and S4. So the behavior is just as follows. if AS4 runs EFG URPF algorithm A, there will be improper block problem and interface 1. And if AS4 runs EFG URPF algorithm B, okay, there may be also improper block problem and interface 1. Okay, this is just one case for improper block problem. And there is another scenario also for the improper block problem, which is in the case of DSR, that is a direct server return in Anycast scenario. So Anycast is a very popular technology used in today's internet. In this figure, we just assume that there is a user located in AS1, which sends a request to the Anycast server located in AS5. Okay, the destination address is the Anycast address. However, the edge server is located in AS2. Then the Anycast server will just direct the request by a tunnel to AS2. And when the edge server in AS2 finally replies to the original request in AS1, it will just take the Anycast address as the source address. So it means that, okay, this kind of replying traffic will be blocked by AS4 because this address is not the address of AS2. So in this case, no matter whether we run algorithm A or algorithm B in EFG URPF, there will be improper block problem. And there is another gap, that is the misaligned incentive problem. Okay, this problem is just similar as the misaligned incentive problem in intradomain network. That is, okay, the early deployers of the solve mechanism cannot protect themselves. They can just guarantee that, okay, the traffic originated from this ASs will not, okay, forge the other network, but cannot protect themselves. To summarize, for existing interdomain solve mechanisms, it has two major problems. The first problem is inaccurate validation. That is, it may cause improper block or improper permit problem. And the reason is that the EFG URPF, okay, mechanism also conducts the solve based on local RIP of the routers, which may not match the real data plane forwarding path from the source. And the second problem is the misaligned incentive. That is, okay, it may just suffer the reflection attack even when the solve mechanism have been deployed by the victim AS. And the reason is that, okay, the EFG URPF algorithm does not participate in protecting its source address from being forged. Okay, so the requirement for a new interdomain solve mechanism includes the following. The first requirement is that the solve mechanisms should discover the real data plane forwarding path among the routers or ASs. And the second requirement is that the solve mechanism should provide direct incentives to the early deploys of the new mechanism. And the third requirement is that the solve mechanism should not, okay, introduce too much overhead. Next, we will describe our recent software solution, okay, proposed in IETF. The basic idea of the SoftNet includes resilience, correctness, incentive, and cost. For resilience, it means that each router should build a soft table to validate the source addresses. And it means that if the prefixes are not learned in the soft table, the incoming packet will be permitted. While if the prefixes are learned in the soft table, but the incoming interface of the packet does not match, the packet will be blocked. Okay, this kind of mechanism will be more resilient than single hop chicken and ingress routers. And for correctness, it means that the router's soft tables should follow the real forwarding path in the data plane of the routers to ensure the correct validation even with asymmetric routing. And for incentive, it means that the source prefixes of the deployed areas, whether they are sublets or ASs, should be disseminated as far as possible. And the traffic forging these source prefixes can be blocked as close to the source as possible. And for the cost consideration, we just want to design the new mechanism by extending existing control plane protocols without data plane packet modification at all. So by the sublet idea, the routers, in future internet will just add a soft table besides the FIP table. So when the packets, come in, we will just, the package will be first checked by the soft table, and then go to the FIP table to look up the, forwarding interface. And for the soft table, the key is the source prefix of the packet, and the destination, the value is the incoming interface. And the information of this soft table are learned by a distributed protocol, which is, we call the subnet protocol. So the purpose of the subnet protocol is just to generate the soft tables among the routers. And the subnet protocol architecture is, just like this. We just, this protocol is a free distributed protocol. And we just use this protocol to discover the real data plane forwarding paths by hop prefix notification, and generate the subtables in routers along the paths. In the high level, actually, we just separate the protocol into an interdomain part and an interdomain part, both sharing the same high-level idea. And the protocol messages includes just two main fields. One field is about source prefix field, and the other is about the propagation scope. The source prefix field in the protocol message just contains the source prefix of the initial node of the network. And when a node, no matter it is router or AS, it just generates the soft rules in local routers for the source prefixes. And this field remains unchanged during the prefix notification process. And for the propagation scope field, it just contains a list of destination prefixes which take the neighboring node as the next hop from the FIP. This FIP is used to discover the real data plane forwarding path, and it remains just changes hop by hop during the prefix notification process. We use an example to show the protocol workflow of the softnet protocol, how to generate the soft tables along the routers. So due to the time limit, we just will not go to the details. So actually, during this notification process, every router will generate the notification message and also generates its soft table to help correctly filter the incoming traffic. During the protocol notification process, we also need to enable update. That is, if there is a topology change or routing change in the internet, we should enable the routers to update the protocol. We provide two possible update mechanisms. That is periodical update and a triggered update. For periodic update, it means that each initial node will generate a protocol messages periodically. And a triggered update, it means that when the routing state changes, the initial node will generate protocol messages to add the updated sub-rules for the outdated sub-rules. And we suggest the interdomain subnet protocol to support both periodical update and a triggered update, while the interdomain subnet only supports triggered update. I just use one slide to summarize the this work in IETF. Actually, our team in Tsinghua University has worked on this topic for many years. And in March this year, we proposed a BOF, the sovereign BOF in IETF. The BOF just the problem statement and the solution ideas receive wide acknowledgement from the community. And only after, just 3 months later, in June of this year, IETF decides to form a new working group, that is the subnet working group in routing area. And we also have successfully held the first working group meeting in IETF 114 just in last month. So we have a mailing list here for any colleagues, no matter the professors or engineers or students. If you have interest in the source address validation topic, so welcome to join this working group and just subscribe to this mailing list. Okay, that's all of my presentation. Thank you very much.
Thank you very much, Professor Lee. This is a very interesting practice of the source address validation mechanism in the Internet. So if you're interested in this research, as Professor Lee mentioned, you could join this group, working group in the IETF, and you could share your ideas and share your questions in the working group. So let me check if there is any questions online.
Hello? Okay, sorry, Angie, I cannot hear your voice, so can we start? Okay. Thank you very much for introductions. My name is Shinji Shimojo from Osaka University, and also I'm representing the APAN JP now. So can I share my slides? And I hope you can see my slides, correct? Okay, so I think I cannot hear your voices, but I will start. Today, I would like to talk about the designing of future society for our lives towards Expo 2025 and Society 5.0. First, I would like to congratulate the APAN 54th in Jinan. Thank you for your effort in Chinese group, local group, to support this big conference. I'm sorry I cannot be there. I think I would like to meet my old friend Jampiu or Jerin Wan, Anji, and other friends in APAN. It's been a long time since COVID. We couldn't see each other, but we have to, recover very soon, and I hope we have to see you next time. So today I would like to talk about the two things. One is my background, that is APAN JP, and the other is about the Expo 2025 in Kansai, Osaka. Okay, first I would like to talk about APAN JP. APAN JP is a coalition of interoperable network for Japan and international. It's a coalition of several network operators like ArenaPac, Muffin, NSCT, Cynet. So I will briefly introduce their current status. But we are coordinating the network operation by APAN JP NOC, Network Operation Group, so that we will provide the various connectivity around the Asia Pacific and the world as well. And Konishi-san from APAN JP also dedicated to have the network engineering workshop in every APAN. It will be held in August 24 and 25. And there mostly covers those, network background and operations. So I will very briefly talk about these. First, I would like to introduce the speaker mode. Okay, so I would like to change. I hope here is okay. Thank you. First, I would like to talk about the ArenaPac. Although this is a very new initiative, but for the alphabetical order, I will introduce them first. They are operated by the WIDE group. ArenaPac is the arterial research and education network in Asia Pacific, and also they are operated by the WIDE group, and the project itself is supported by the Asia Pacific Internet Development Trust, supported by the APNIC. And also they full collaboration with other NREN and also the APONET. And the mission is develop the intra-regional infrastructure with AIII and other partners, and to promote the operation and development of the new Pacific topologies with United States through participation of GOREX. And the mission to Asia Pacific Rim to connect the Asia Pacific region to the rest of the world globally. Their development is like that. So now they have Tokyo Guam link, and also they have Guam Singapore link. And it will continue on to the Guam Maran and the Guam Manila late this year. So the infrastructure itself is like that. So that through Guam we have several network connection right now, and the benefit of that is the new applications like we have a big telescope in University of Hawaii. And nowadays, the National Astronomical Observatory of Japan wants to, use telescope remotely. Before, the ArenaPac, their latency is very big. It's 170 milliseconds and 9 hops. But after that, after the arena pack, they are improved in 96 millisecond and 3 hops like that. So the red line turns into the yellow line like that. And the second group is MAFFIN. MAFFIN is a Ministry of Agriculture, Forestry, and Fishery Research Networks, and they support the agriculture, forestry, fishery research throughout the Asia and the world. So they support some research data obtained from the international or internal or international sources to share those data into the Asia Pacific regions. So their connection is like that through the MAFFIN. They are supported. They support many research institutes within Japan and also the internationally. Their institute is actually distributed throughout Japan in like in this figure, so that they support the the agriculture related project. The next network body is National Institute of Information and Communication Technology, NICT. NICT is the only public research institute specialized in ICT. They have some public services like Japan Standard Time or Space Weather Forecast, like that. And their main research area is advanced electromagnetic wave technology, innovative networks, cybersecurity, universal communication, frontier science. They also fund some research like US-Japan project, EU-Japan project, ASEAN IBO is a kind of Asian project, also Taiwan-Japan project. The highlight of their research fields is like beyond 5G, quantum ICT, cybersecurity, and AIs. They are now open up the new testbed called Beyond 5G IoT testbed with high reliability and high elasticity. Within this platform, in the platform layer, they have a platform for the data-centric cloud services. And in the middle layer, the combination of the cyber-physical system to the real system, which is called the Real Demonstration Environment, is supported by the Starbed, its big clusters in Hokuriku region. In the network layer, they also support the Beyond 5G mobile environment, which is extension of the 5G. And they also support Beyond 5G virtualized infrastructure service environment. The last, the network operation body is called SciNet, supported or provided by the NII, National Institute of Information. SciNet is a ultra-high speed academic network dedicated enhancing research and education activity of university and research institute in Japan. SciNet has a high-speed internet as well as high-speed layer 2, layer 3 VPN, the closed network, and also they have a mobile SciNet as well. They are actually migrating to SciNet 5 to SciNet 6 right now, and SciNet 6 in nationwide, they have 400 gig backbone and also the additional nodes. They also have a 5G mobile network and the private 5G as well. The flexible service by NFB and routers are provided throughout the network, and the two 100 gig network for the international and more for the international lines. Now the international lines is like that. I think detail will be covered in the network engineering workshop as well. So, but anyway, through the coordination of the APAN JP, we have a very rich international network within Asia and also to Europe and US. I'd like to thank all the collaborators of this network. Next, I'd like to talk my private interest, which is designing future society of our lives. We are in Japan. We call it Society 5.0, which is, I think, most modern society structures beyond I think the first is hunting, the first generation. The second is agriculture. Third is industry. Fourth is information society right now. And the 5 is beyond the information societies. So that is, I think, Japanese motto right now. And this is actually the theme of the next exposition in 2025. So in 2025, actually, exposition will be held in Osaka, Kansai, in an artificial island called Yumeshima. This is a place. We are now building the artificial island beyond the Osaka Bay. This is actually the next, the first exposition after the Shanghai exposition. So I think we have to inherit your culture as well in the forthcoming the next exposition. Shanghai, Dubai, and Osaka. The topic theme of this exposition is designing future society of our lives, and the sub-theme is saving life, empowering life, connecting life. But interesting for the researchers or engineers is we think that the exposition is an opportunity for the people's living lab or laboratory for the future society. Society 5.0 is very difficult to achieve. We have many problems like carbon neutral or how to use the data for our lives is very important, and also it's very difficult, sensitive issues. So to resolve those issues, we have to, as a scientist, we have to do some experiments or social experiments. So this is the concept of our next exposition. So actually, in Kansai, Osaka, we are accelerating towards the well-being smart cities. Osaka was actually appointed as a super city in last July. Super city is kind of super smart city. In Japan, 2 cities are selected. One is Osaka and the other is Tsukuba. So now the construction of smart city Osaka was started. And we have some actually feasibility study or experimental city built in north part of the Osaka station, which is called Umekita. And so if you have chance to visit Osaka, please visit the north part of Osaka station. It's a big complex of the commercial and also the buildings. But they are very experimental city so that you can experience the new technology right now. And the second phase of the Umekita will start it, and also it will completely open partly in 2024. Preparing for that to use data is most important, so that the Osaka University conduct research for Society 5.0 started. And Expo 2024 will be coming, so that we are now preparing for the well-being smart city. So I will briefly talk about the Osaka Super City concept. The concept itself is health and inochi or life enhanced by data. We have two green fields. One is Yumeshima construction, so it's a construction site of the Expo 2025. And the second green field is Umekita Phase 2. In the exposition, we have a big constructions. Expo 2025, we have a big constructions. So for the safety of the transportation and also the optimization of the transportation, we will do many trials like using AUV for the construction and also the monitoring the workers' environment for their safety. In the Umekita Phase 2, we also use the personal data for visitors or workers at Umekita for their health. This is an overview of the smart city. So to improve the quality of life citizens and also to strengthen the competitiveness of the city, we have a vision of the optimal transportation, smart mobility, and also the health longevity society. But for that, data is very important. So we are aiming to open up the new business innovations using the data. For advanced services, transportation, logistics, medical service, healthcare, and town planning, disaster prevention, we also conduct on. So those services are developed by the data. And to have a common data, we will set up the Common Data Federation Infrastructure, which is called ORDEN, Osaka Regional Data Exchange Network. Using ORDEN, we can have a federation of data generated in the different components. So in Umekita Phase 2, as you may see, the current Umekita city is actually the JR, National Rail carriage area, is turned into the park and shopping mall and the business district, residence, something like that. But we are aiming to provide the advanced health service here to use the data of each person. So health enhancement program by human data and AI will be planned. We have athletic gym and also the swimming pool. And we're also interested in the emergence of the real and cyber spaces. So we have a sensor so that if you have a real world activities, it turns into the digital twins and we can simulate some activities here. The basic of these, data handling, the ORDEN, the data federation infrastructure, could be used for connecting different sectors and exchange data through it. But the important thing to treat the data related to the human is the data handling regulations and also the consent for each person. For that, we are doing the research initiative called the Initiative for Life Design Innovation, research conducted by the Osaka University and the Ministry of Education. In this research, we are aiming to create the future society leveraged by the personal data. We are thinking that living with robots, also the new lifestyle is engaged by the sensors, like a mobile sensor or other environmental sensors. We have a home care monitoring and also the learning support. While we are learning, we are monitored and their efficiency is measured, and AI provides some advanced learning support. The well-being is also considered by the monitoring, and the well-being with sports is also other activities. This is a video, but I skipped that because this is only in Japanese. I tried to translate it in automatic translation, but it's very heavy Osaka local dialect, so it's very difficult to translate. If you are interested in, please look after that. The most important element for those data management is personal life record. We call it PLR. PLR is the extension of the PHR, personal health record. In the health record, height, weight, blood type, or those kind of health-related information is stored in the health record. But as an extension of that, personal data and the living environment data in daily life is very useful to monitor the personal activities or their behavior, like face figure expression, behavior, or location, activities, situation, event environment. So those kind of data is taken through the watch or other sensors, the body sensors, so that we integrate those information with the PHR. So this is the basic concept of our project. And using those PLR, we develop the advanced service like edutainment, life cycle, or wellness. For example, in the wellness, we monitor the first 1,000 days of newborn child, including the mother. So when they are at home, they are monitoring by sensors, and also if a child is in bed has many sensors, so that those information is used to monitor their health. And we also have watching over the elderly people with fertility, and also heart failure, home-based rehabilitation is monitored at home. Those research are conducted with a collaboration with Osaka University Hospital. The most important things about those kind of research is privacy policy. We set the privacy policy as no one could be harmed by undesirable data transmission or data usage. In some survey, there's actually anxiety about providing personal information, like 78% in 22 and 66% in 2021. So that we are very much care about privacy policy, and collaboration with a lawyer and psychological researchers or some LC LC specialty. We set the rule and also the handling policy for the data management. Those personal data is collected using the dynamic concept, so that if industry or other research body wants to use their personal data, they first send the request, and if the person can allow these use, they do some agreement, and the quote agreement is done, and through the quote agreement, the data could be used for those bodies. So we implement those dynamic consent mechanism into the PLR system. So this is the infrastructure for the PLR handling. Using those dynamic consent, data is through from the left side. Left side is research bodies, and right side is some pharmaceutical company or industries or research bodies wants to use those data. Through the dynamic consent, data is flows through left to right. I think there's 3 use policies for the personal information. Personal information can be used for public, that governmental pool, and the personal information should be used in some balance between person and collectors. This is normally happen with the industry. And personal information should belongs to each person. This is based on the GDPR, and we are doing the same thing as introducing the dynamic consent. But I think in those public data use policy is very difficult to handle data. And sometimes data is collected but could not used and ruined. So we may need some more relaxed data use policy. I call it the force approach. Like if you're living in a small town, you know that who's living and how old are they, and they are healthy or not. So like that, in small community, we can share some information without the allowance, so that we think this kind of personal information management by the community can be a new approach. And if there's a chance, I would like to try that in Expo. So as I said, Expo 2024 is very different than the last Expo. It's very unique for building Expo for everyone. So everyone can join to build or to do something with Expo. For example, they are open to Team Expo mechanism. You can propose some research or some service in Team Expo and do it in Expo 2025. At the same time, Osaka City are open to build their smart city, and that is Osaka Smart City Partner Forum. If you propose some project, we can have some joint project to make new service in Osaka. And the entity actually wants to provide the new network service with, and tried it in Expo. That is called IOWN, Innovative Optical and Wireless Network. That's all optical network. So that I think there may be some opportunity for network research to do something with Expo 2025. And the other thing is on the right corner, we show the VTuber. This is very popular in Japan right now. The old people are living, it's YouTuber in animation format, and they are living in the metaverse. But metaverse is actually supported by the information infrastructure. So I think as a research, as a networking research, we can have many things collaborating in Osaka City and also the Expo 2025. One example conducted in Osaka University students is APAN. In the Osaka University students, they want to do e-symphony. That is a synchronized symphony, but the people are distributed around the world. So 100 countries, the students living in 100 countries synchronized in a symphony through the network. That is their dream. I think APAN is contributing the e-culture a very long time, so that we can have some collaboration with them. So my final word, let's join us, and please come visit Osaka 2025. But before that, we would like to have some joint collaboration in APAN. Thank you very much for your kind attention. I hope you can hear that. I cannot hear you.
Thank you all very much. Bye-bye.